How to fix Battlefield 1 freezing on loading screen with audio playing. Welcome back to Teknobalta. During our rigorous technical testing of Battlefield 1 on modern hardware configurations, our diagnostics team identified a persistent and frustrating issue where the game completely freezes on map loading screen, such as FAU Fortress or Gallipoli, while the background ambience, music, and UI audio continue to play normally. Our in-depth investigation revealed that this state occurs when the Frostbite engine's rendering thread encounters a severe desynchronization or a hardware-accelerated conflict, causing the visual display to lock up while the game's audio processing thread continues running in the background. After running extensive simulations and diagnostics, Teknobalta has uncovered a series of definitive technical solutions ranging from background frame generation conflicts to memory leaks and DirectX API mismatches to ensure you never experience this freezing again. Our first major discovery targeted third-party frame generation and scaling tools, specifically lossless scaling, which can cause severe buffer management conflicts with Battlefield 1. When running the game alongside lossless scaling, the software injects an external presentation layer that directly disrupts the Frostbite engine's exclusive full-screen flip model behavior during map transitions. Teknobalta's testing confirmed that disabling lossless scaling entirely or forcing the game to run without any external spatial or temporal scaling utilities instantly restores the engine's natural rendering sequence and eliminates the freeze. If the issue persists after disabling third-party injection tools, our diagnostics point toward an active conflict within the Frostbite engine's DirectX 12 implementation. We tested this specific variables and concluded that the DirectX 12 renderer in Battlefield 1 suffers from chronic pipeline state object caching issues that trigger freezes during high-load map transitions. To resolve this, you must navigate to your Documents folder, locate the Battlefield 1 settings directory, open the profsav eprofile file with a text editor, and modify the GST render. DX12 enabled variable from 1 to 0 to force stable DirectX 11 execution. Another frequent culprit identified during our technical analysis is a corrupted DirectX shader cache, which stores broken rendering pipelines that fail to load when a new map initiates. When the game attempts to call these corrupted assets during screens like FAU Fortress, the GPU driver crashes silently while the CPU continues processing game audio. You can quickly eliminate this by opening the Windows Disk Cleanup utility, selecting your operating system drive, checking the box specifically for DirectX shader cache, and running the deletion process to force a clean recompilation. We also uncovered significant stability anomalies tied to full-screen optimizations handled by the Windows Desktop Window Manager. Our team verified that these optimizations can sometimes force an unstable hybrid presentation mode that causes the GPU to hang when the game switches asset contexts during loading screens. To bypass this, navigate to the Battlefield 1 installation folder, right-click on the main executable file, select Properties, open the Compatibility tab, and place a checkmark next to disable full-screen optimizations. Our investigation further revealed that modern background overlays, specifically the Origin successor EA app in-game overlay, cause intense thread contention during map loading. The EA app constantly hooks into the game's DirectX swap chain to prepare notification overlays, which directly interrupts asset streaming pipelines during level loads. Teknobalta recommends launching the EA app, opening its global application settings, navigating to the application section, and completely toggling off the in-game overlay switch. In addition to the EA app, Discord's hardware-accelerated overlay is another primary source of asynchronous rendering freezes that we successfully diagnosed. Discord forces an external hook onto the graphics API, which can cause timing desynchronization between the audio thread and the primary render thread, when the CPU utilization spikes to 100% during loading sequences. Disabling the Discord game overlay within the user settings under the game overlay menu removes this specific bottleneck and stabilizes asset loading. Our deep dive hardware testing also showed that unstable graphics card factory overclocks can trigger a silent TDR, or timeout detection and recovery, event where the display driver resets but the audio subsystem remains operational. The heavy multi-threaded asset decompression that occurs during Battlefield 1 map transitions places a unique, transient load on the GPU core voltage. Using a utility like MSI Afterburner to underclock your GPU core clock and memory clock by a modest 50 MHz can provide the necessary voltage headroom to prevent these loading screen hangs. Furthermore, out-of-date or improperly overwritten graphics drivers frequently contribute to the Frostbite engine failing to transition between loading cinematics and the 3D map environment. Residual registry entries from previous driver iterations can cause asset allocation failures within your system's VRAM. We highly advise downloading the display driver uninstaller utility, executing a clean driver removal in Windows Safe mode, and then performing a pristine installation of the latest WHQL driver available from your GPU manufacturer. Teknobalta's technical team also ran diagnostics on system page file configurations and uncovered that restricted virtual memory allocations cause the game to freeze when caching large multiplayer maps. Battlefield 1 demands massive virtual memory pools when transitioning from the story mode or preloading complex geometries like Gallipoli. You can fix this by accessing Advanced System Settings, clicking Settings under Performance, moving to the Advanced tab, clicking Change under Virtual Memory, and setting a custom size with a minimum of 1.5 times and a maximum of 3 times your total physical RAM. Another hidden variable we uncovered is related to aggressive Windows power plans that dynamically downclock CPU cores during brief periods of low rendering activity on loading screens. This sudden drop in processor frequency interrupts the critical handoff between the CPU loading assets and the GPU rendering the loading wheel. To prevent this performance fluctuation, open the Windows Control Panel, access Power Options, and change your active plan to High Performance or Ultimate Performance to lock your CPU at its base operational frequency. We also analyzed localized game file integrity, which remains a frequent point of failure when specific map files become partially corrupted during updates or hard drive write errors. If the specific archive block containing FAO Fortress texture coordinates is unreadable, the audio stream will continue while the asset loading thread encounters an infinite loop. Launch the EA app or Steam, navigate to your game library, right-click Battlefield 1, select Properties or Manage, and choose the Repair or Verify Integrity of Game Files option to restore broken data blocks. During our network-level diagnostics, our team found that strict or misconfigured firewall rules can cause a thread lockup when the client attempts to synchronize multiplayer state data while loading the map geometry. The visual engine pauses waiting for a server handshake that is being actively blocked or delayed by security software. To alleviate this, navigate to the Windows Defender Firewall settings. Select Allow an app or feature through Windows Defender Firewall, and ensure that both the Battlefield 1 executable and the EA app have explicit private and public permissions enabled. Our testing also revealed that memory leaks stemming from the Windows Network Data Usage Monitoring driver can trigger unexpected game freezes by exhausting non-paged pool memory during map loads. This network driver conflict leaves insufficient system resources for the Frostbite engine's asset streaming worker threads to complete their cycles. You can resolve this by opening the registry editor, navigating to H-Keylaka Machine, System, Current Control Set, Services, NDU, locating the start word value, and changing it to 4 to completely disable the monitoring service. Another crucial adjustment discovered during our performance profiling involves the dynamic throttling mechanics of the Xbox Game Bar configuration built directly into Windows. The Game Bar's background recording feature constantly writes temporary video data to your storage drive, creating a severe I/O bottleneck when the game is simultaneously trying to read map assets. Head into your Windows Settings app, click on the Gaming category, select Captures, and completely disable the option for record in the background while I'm playing a game. We also diagnosed a rare conflict with the Nahimic audio service or similar third-party audio enhancement software suites pre-installed on many modern motherboards. Because these utilities attempt to inject spatial audio layers directly into the game's active audio thread, they can cause a severe timing desynchronization if the rendering engine pauses momentarily to stream map assets. Opening the Windows Services Manager app, scrolling down to the Nahimic service, changing its startup type to disabled, and stopping the service will immediately eliminate this audio-induced rendering stall. Our technical evaluation further demonstrated that running the game in windowed borderless mode, rather than exclusive full screen, can dramatically stabilize map loading transitions when background applications are active. Windowed borderless forces the game to use the operating system's compositing engine, which prevents the GPU from resetting its display state during heavy asset shifts. Launch the game, navigate to the Video Settings menu, and alter your full screen mode setting to borderless to ensure smoother display synchronization. Finally, our engineering team discovered that high polling rate gaming mice can actually cause micro stalls and absolute loading freezes within the Frostbite engine when the CPU is running at maximum capacity during map setups. Interrupted data packets from mice polling at 1000 Hz or higher can flood the game's main input loop, stalling the asset initialization process. Lowering your gaming mouse polling rate to 500 Hz or 250 Hz within your mouse manufacturer's software suite during gameplay solves this hidden hardware conflict. Don't forget to follow Teknobalta for more.